talk is very clear. I mean, you talk of very complicated topics, but you make them sound very easy to understand. So that's what I really want to do right now, like to understand where does this idea of recycling batteries come from, and then how did it all begin?
Okay, sure. Let me begin. So, my name is Taha. I'm 30 years old by now. Born and raised in Germany, and I studied engineering in Karlsruhe. And my journey with electric vehicles began with my job at Mercedes-Benz, where I was a project manager for the first 100% electric model series. And it was always about getting batteries into a vehicle and calculate the return on investment and stuff like that. And my hate love towards recycling came with a issue that we had, and that was basically the battery was around 40% of the cost of the electric vehicle. So when we calculated the business case, there was the danger that when we have to replace the battery during the guaranteed time, it is on our cost. So if you have a 10% return on investment of your project, and then you have to replace the battery on your cost, which is 40%, so suddenly your return on investment is minus 30%. And then we started into looking on, okay, in this case, how can we utilize those batteries? How can we do something with it? And we studied like remanufacturing, which means like try to take the batteries, repair them and put them back, or put them into energy storages, but also we analyzed recycling. And back then, their only recycling processes that were feasible for lithium-ion batteries were shredding and crushing those batteries down and then try to somehow extract the critical minerals. But we discovered that economically it doesn't make any sense. And then to my luck, there was a project with a university which I was able to enter, and there we analyzed first time direct recycling, which was basically like instead of shredding, you're taking the battery cell apart and then you're washing the cathode material off the foil with some chemicals like natrium hydroxide and stuff like that. And based on that investigation, Novocycle was born with the idea to build the first non-chemical dry direct recycling process. That was how everything began. And since then, we're working on that.
So you basically were investigating in the university about how to recycle them, and then you find out that that method you just mentioned worked as a direct recycling, right?
I didn't discover that dry direct recycling in university. I just discovered the chemical one. And then when I went off together with Fatih, we discovered that we can do it dryly, which is solving a lot of problems, because every time you're using a chemistry, you need chemical process to remove the chemistry. So when you wash off those cathode materials with chemicals, that means that you have a liquid in which those materials are, and then you need the chemical process again to get the metals. And then if you do the calculation in the forecast of business development, business analysis, then you were able to see that when you use chemicals, your OPEX becomes increasingly high. So that's how we discovered that today's processes will never reach profitability for lithium-ion battery recycling. So Novocycle is here to solve that and bring profitability to the recycling industry. I hope that was clear.
Yeah, that's such an important topic because we need to make basically recycling profitable. So brands are interested in recycling, because nowadays they are not even interested in recycling because it's, well, costing them money. So if it's something that it's profitable, we can incentivize brands to recycle.
Exactly.
So let's say Mercedes, in that time when you were working, were they responsible for the disposal of those batteries, or who is responsible for those batteries?
Since the new EU battery regulation, since 2025, the OEM is responsible for the disposal of the battery. The OEM could be the battery manufacturer if he didn't sell it to another product. But if you're a car manufacturer and you bought in the battery and placed it into your car, then you are the OEM. So that means that the in-market bringer of the battery is responsible for the disposal of the battery with the new EU battery regulation, or what the new EU battery regulation allows you is to become a member in an association, and then you give this responsibility to the association, and this association solves this issue for you. That's how the regulations are today.
And that association is supposed to recycle, to repurpose, or to do whatever is needed. I mean, what's the purpose of the association?
The association is like responsible to manage those waste streams. So in those associations, you usually have OEMs, but also recycling companies and other things. So the association says, okay, there is a 50,000 tons battery end of life from company X. He files it, and then he searches for recyclers within the association, and then those recyclers take the batteries, and then this is how it gets managed. So it's like building alliances to ensure that the recycling is done correctly.
Okay, here I have a question about what does circular economy mean to you, and why is it so important for Novocycle?
Circular economy is unfortunately greenwashed a lot today, and based on that greenwashing, we could even say that Novocycle was born with the rebellion of ending the greenwashing. The problem is, circular economy for me means that you have a product made out of critical minerals or other materials, and then you are getting those materials back with recovering them. But then circular economy should mean that you then take those materials and place it back into the supply chain. What should not be circular economy is if you shred things down and then you have a lot of waste and you're only recovering 25% and 75% gets residue, and you just ship it to a burning industry and then those materials get burned to create energy. That is not circular economy. And that is why Novocycle is focusing on recovering as much of the materials as possible. Today we reach a 96% recycling rate of all solid materials, with a purity of 99.5% for the active materials and a high purity for the metals like aluminum, copper, etc. And we're giving that to metal companies that are then recycling those metals and putting it back to their supply chain. So circular economy should also always be focusing on reintegrating those recovered materials back into the supply chain, not getting it into landfill or burning it away or stuff like that. And that is a big problem right now in the industries, that there is a huge opportunity to greenwash things just to make it sound nice, but it really is not.
Yeah, what I've been reading about our process in Novocycle is that we, instead of shredding, well, we dismantle, right? When we dismantle, we separate the cathode and the anode materials from the separator, which is a plastic separator sometimes. And then that cathode and anode are like a powder, basically. Is that powder ready to be reintroduced into new batteries when we extract it?
So maybe to explain that a little bit more in detail. So what we do is we created an automated machine that is automatically opening the cells. And as you mentioned, we're separating the anode, the cathode, and the separator. However, the anode and the cathode are still a foil, a metal foil, plus some active material stick onto it. So first thing you need to do is to make sure that you can remove the powder from the aluminum foil on the cathode side, or the graphite powder from the copper foil from the anode side. In order to do that, we have developed a special treatment within a specific atmosphere under specific pressure to evaporate the PVDFs, so the binders and the electrolyte. And after that, we were able to separate the powder from the metal foil. And once we did that, there is a second treatment where we are baking those materials. So we're impacting them with the powder is impacted by a higher heat than the first process. And there we are removing the last organic compounds, and we're increasing the surface area of the particles. Imagine it like a ball that has like scratches and some lunkers in it. And then with the heat treatment, you're putting air into the ball so the ball gets big again. And that is what we do. And after that, You just need to granulate the material into your specific particular size, whatever you need that is specific to you as a customer, and then you can reintegrate it into a new battery. And we successfully reintegrated the cathode and the anode active material that we recovered into a new battery, and the battery worked with up to 99% performance compared to virgin materials. That is also a huge success that we did with Novocycle.
Yeah, that's amazing. So it's actually closing the loop, as you were saying, the circular economy. We need to close the loop. There's something that I've been always curious about. How do you know they are in their end of life, and how do you know they can go to repurpose in other aspects like energy storage and other uses?
There it makes sense to explain it with mobility-based batteries. So batteries have especially lithium-ion batteries have a specific point that is called knee point, and that goes for nickel, manganese, cobalt mixture batteries. And in that knee point, you can imagine your capacity is decreasing over time. So you charge it and discharge it, so it loses the capacity, and then at around 69 to 71% rest capacity, you have a knee point, after which it suddenly drops. And then companies like OEMs or automotive companies, they don't want the customers to see that capacity drop, because it would cause a huge complaint on side of the customers. So that is why those OEMs say that once the capacity reaches 80%, they state it as end of life, and then they take it out of the car and the battery gets replaced. However, that capacity decrease is faster, because with the car you have you put the pedal, you increase the speed, you put the brake and stuff like that. So there's a lot of zigzag impacts on your battery, and that is why the capacity is dropping. Now, if you take it out with 80% capacity and you put it into a energy storage systems that has a constant current, so you charge it and discharge it with the same current and with the same energy load, and there it can live for another 5 to 6 years before you need to recycle it, before it reaches those knee points. However, that is different in LFP batteries. LFP batteries have a really constant capacity until the end of life, and then it suddenly drops. So LFP batteries live longer, but you cannot easily detect the rest capacity of the LFP batteries. That's why most likely repurposing makes much more sense for NMC batteries.
Okay, so when we recycle the cathode and the anode and we extract this mixture of materials, what we just said, they can be reintroduced into new batteries, so they are actually not deteriorating. But what does deteriorate to get the battery to lower capacity? What is the thing that goes wrong that makes the capacity go down?
I mean, there are a lot of factors. So as I explained, with the second heat treatment, we're healing the materials because they get degraded. So there's lunkers and stuff like that. Then the second thing is that with time, you need lithium to jump from anode to cathode in order to charge and discharge your battery. So that lithium gets less and less. And when the lithium gets less and less, your capacity is dropping. But then you also have the separator between the anode and the cathode, which is a microporous foil that avoids the short circuit between the anode and the cathode, and it has holes that are just so big that a lithium ion could jump through, and anything else doesn't go through it. And with that is that during the time charging and discharging, those holes get filled, so you have less lithium that is jumping, which makes the battery slower. And then also there's the effect of building dendrites within the electrolyte, so you have a lot, think of it as crystals that are growing in your liquid, and that is also slowing down the process from the lithium to jump A to B, and also hindering it. And dendrites could be even really dangerous, because if they grow too much and they're putting a hole through the separator, you get a short circuit and then your battery can explode, for example. These are the effects how a battery gets degraded.
Okay, that's very clear for me, at least. And then I have one last question, Taha. Beyond business success, what impact do you want the company to have on the world?
I mean, Novocycle is here to enable industries, enable the recycling sector, enable battery manufacturers to treat their production scrap. So what we are dreaming of is building a huge recycling network of micro facilities that are decentralized over the world, so that the waste doesn't need to come to facilities, but the facilities are coming to the waste. And with that, we're aiming to reduce the carbon footprint of the battery supply chain by over 50% in the next 10 years, and at the same time reducing the transportation distances to really make battery recycling profitable. Because sustainability is always nice, but it is always just call it a miracle, or not a miracle, but more like a dream that everybody dreams of, that never can be fulfilled if there's no profitability. Because at the end, we are in a commercial world. So if you have in a commercial world something that is eating your money, at some point it will crash. And that is our mission. We don't want battery recycling to crash. We want to give the regions and the nations independency, to be more independent with critical minerals, so that they can source their own critical minerals from secondary sources like end-of-life batteries. And that is our dream, bringing true sustainability, bringing independency for the regions, and decentralizing the battery recycling in the world.
So that sounds fantastic, and I'm sure we will. We're in a good path to
100%.
achieving it.
100%.
Taha, thank you very much.
Thank you.
Everyone enjoyed and understand a little bit more about this world of battery recycling.
Perfetto.